Hello students, welcome back to all. Nice to meet you again. This is Gopal from Department of Chemistry, Bharathidhasanar Matric High Secondary School, Arakkonam. And our new branch is established in Kaveri Pakam. Today we see 12th standard second unit P block elements part 1. In 12th standard you have two parts in P block elements. The first part is included in second chapter and the second part of P block element is given in third chapter. Today we see the first part as a second chapter. Let's see. What are P block elements? The P block elements are being in the right side of the periodic table, in which the group 13 to 18th groups are called as P block elements. The first 10 elements in the P block is boron, carbon, nitrogen, oxygen, fluorine and neon. So these are the first P block elements line, and let's see, this P block elements contains the boron, aluminum, gallium, indium and thallium as in the first group. In this group only the boron metal is the non-metal in this group. The boron atom is the non-metal in this group and the aluminum, gallium, indium, thallium is the metals in this group, in which the groups are numbered as 13, 14, 15, 16, 17 and 18. So from 13 to 18th group elements are called as P block elements. In P block elements part 1, in this chapter we see 13th group and the 14th group. Okay. In these groups, let's you see, the vertical lines are called as columns or otherwise called as groups, and the horizontal lines is the rows, it is called as periods in these groups. So this is the second period, third, fourth, fifth and sixth periods in this group, because the first element which is present in the first period is a S block elements. Hydrogen and helium is present in the first period, that are in S block elements. So P block element starts with the second period. The second period elements contains the electronic configuration 2p. Why it is called as P block elements? I will say now. In these elements, the last electron enters in the p orbital, so only it is called as P block elements. Especially you can see that, see now, the elements contains same orbital as the last orbital. Boron, carbon, nitrogen, oxygen, fluorine and neon all are having the same orbital as the last orbital. That orbital is 2p. So the last electron enters in the 2p orbital. How many electrons can be fulfilled by 2p orbital? 2p 6. Good. So 6 electrons can be fulfilled by p orbital. That's 6 orbitals are fulfilled by a single elements. But boron fulfills 1 electron in the 2p orbital and carbon fulfill 2 electron in 2p orbital. As like that, and finally neon occupies all the electrons, 6 electrons in the 2p orbital. So this is the electronic configuration of p orbital. And aluminum, silicon, phosphorus, sulfur lines takes 3p orbital as the last valence orbital. So this orbital is fulfilled by these elements, and gallium line is fulfilled by 4p orbitals, and indium line contains last orbital as 5p and thallium lines lastly contains 6p. So only these elements are called as P block elements. P block elements contains the last filling electrons enters in the p orbital. Let's see. In this P block, the boron only the non-metal, aluminum, gallium, indium, thallium is the metals, and carbon, nitrogen, oxygen, phosphorus, sulfur, selenium are non-metals in these groups. What are the compounds are made by P block elements? In the P block elements, the compounds made by the elements are ionic compounds and others are metals and others are metalloids. The non-metal and the metal ions combine together to form the ionic compounds. Every ionic compounds contains one non-metal and metals. For example, let us see, sodium is a metal and chlorine is non-metals. The ionic form of sodium and chloride is Na plus and Cl minus. Both Na plus and Cl minus combine together to form NaCl crystal. And note one point, when non-metal reacts with metals, it forms the crystal structure, and that structured compound is ionic bond containing compounds. So, this compound is made by the ionic bond between metals and non-metals. So, another one point is metal and non-metal combines by only ionic bond. So, this is the point, and let us see the next point. So, p-block elements also contains metals also. What are the characteristics of metals? Metals are shiny, they are good conductors of heat and electricity. They conduct the heat and they conduct the electricity also, and they lose the electrons easily. Metals having high electropositive, so they can donate the electrons to attain the positive cationic charge. So, p-block elements contains some of the metals like aluminum, gallium, indium and thallium. Good students, now I show you what is the general electronic configuration of p-block elements. How can we find general electronic configuration? Before we write the general electronic configuration, we need to find the electronic configuration of such elements. Now I write the electronic configuration of first p orbital entering element. 1, let I write here 1 s2, 2 s2, 2 p1. This is the first atom that contains the first electron in the p orbital. What is this atom? Its atomic number is 2 plus 2 plus 1, 5. Yes, the first element containing atomic number 5 is boron, and our next element is carbon, and then nitrogen, and then oxygen, and then fluorine, and finally we have neon. Let us see students, we need to change the electronic configuration by adding one electron extra, because these elements contains one atomic number extra itself. So, carbon has lastly 2p2, but these items are same, and nitrogen has 2p3, and oxygen has 2p4, and fluorine has 2p5. Finally, neon has 2p6. So, you can see that the p blocks contains the n number in front side, and the number of electrons in the upper side is from 1 to 6. So, I can write the general electronic configuration as n p 1 to 6. When the number is 2 here, the number before that is same number for s orbital. So, np 1 to 6 contains same number with s orbital. So, general electronic configuration can be written as ns np 1 to 6. This is a general electronic configuration of p block elements. And we see the next topic, variation in its groups and periods. How the characteristics or variation in groups and periods, let me see. We have different terms in the p block elements. The terms are atomic radius. One is atomic radius, and another one is ionization energy. ionization energy, and another one is ionization enthalpy, both are same. And next one is electronegativity. Electronegativity. So we have three considered terms in this. And the fourth one is electron affinity. Electron affinity. So let us see here. We need to know whether the atomic radius, ionization energy, electron affinity and electronegativities are increased or decreased in periods and groups. How can you identify? Now I tell. Let us consider the periodic table in which the elements starts from left to right. So elements go from left to right, whether the atomic radius increased or decreased. Let you tell. Whether the size of atom is increased or decreased. Pramin, you tell. Yeah, it's decreased. Good. The atomic radius is decreased and not increased. Why the atomic radius is decreased? Because the distance between the nucleus and the outermost electrons is reduced. Why the distance reduced means the outermost electrons, first elements contains one electron in the outermost valence shell, and then second atom may contain 2 electrons and third one may contain 3 electrons. So when the number of electrons increases, the nucleus attracts all the electrons of valence shells. So the nucleus attracts all the electrons and it reduces the size of the atom. So only the effective nuclear charge increases, the attraction of electron is increases, so the atomic radius is decreases. So only atomic radius decrease in left to right going the period, and others are increased. Ionization energy increased. Why ionization increases? Because when ionization increases, the electron cannot be removed from the atom. When large number of electrons in the atoms, the atom gets a small size. So the electrons are so closer to the nucleus. So the electrons are so closer to the nucleus. Due to this happened, we can't remove the electron from the nucleus. The nucleus strongly attracts the electrons, so we can't remove the electron from the nucleus. It is not easy to remove the electron. So when we easily remove the electron, the ionization energy is low, but it is not easy. We need to spend large ionization energy. So the ionization energy increases from left to right. And let us see the electronegativity. Electronegativity is the energy required to attract the shared pair electron towards itself. Electronegativity also increases from left to right, because when the atoms from left to right, the last atom attracts the electrons more and the first atom attracts the electron less, because the number of electrons is increases, so it morely attracts the electrons. So electron negativity, attraction of electron also increases, and the electron affinity, it also increases. What is the difference between electronegativity and electron affinity? The electron negativity and electron affinity have similar difference, that is, the electronegativity attracts the electron to get a negative ion, and electron affinity is to attract the shared pair of electron. Shared pair of electron means the electron affinity is the reason of forming the negative ion by attracting double electrons. So when attracting the double electrons, the elements gets the negative charge, and this is due to the electron affinity. So electron affinity describes as double electrons is attracted, that means shared pair of electrons is attracted. So this also increases because the attraction needs more when we go to period left to right. So, these are the characteristics of variation of these terms in the groups and periods. And what is for the rows and columns? We need to know the columns as a groups in the period table, and in the groups the atomic radius is increases. In the groups atomic radius increases and ionization energy decreases and electronegativity decreases and electron affinity decreases. Why there are decreases? Because in the column the atomic size is increased. In the column when we coming up to down, the atomic size is increased. So, the atomic radius is increased. When the atomic radius increases, the distance between nucleus and the electrons, the distance between nucleus and the electron is very larger. Due to the larger distance, the ionization energy is reduced and the electronegativity, electron affinity also reduced because of the distance between the nucleus and the electron. So, this is a concept in the variation groups and periods. And let us see our next concept. I say remind you one of the things, that is, in the description I gave you the study material. It contains the study materials made by our school, and the study material contains the lessons book bag 1 marks, 2 marks and 5 marks, and additionally 1 marks, 2 marks and 5 marks also given. NEET and IIT based questions also given. That NEET and IIT based questions contains the steps, how does the answers come. So, the steps includes how does the answers comes also. So, you need to study the study materials and write the self-evaluation test in your test note. Thanks for making time to watching this video. Thank you.